Susie,
Rob,
at the risk of sounding like a serial killer who's definitely got you as my next target, have you ever thought about how you might choose to die if you ever were in that position?
um, not in great detail, but I think I would like to die in a very quick way at a quite old age.
Yeah,
Um, I was going to add to that, but I think I'll probably stop there because I could go, yeah, let's just leave it at that.
too graphic.
So I've just run a marathon at age
Yep,
like 120, and I just
120.
have a bit of a sit down, a snooze, and just pop off. I think something like that, without,
Good.
without illness, basically.
Yeah, that sounds cracking. I think, I was imagining like around a bed surrounded by family members, in relatively health, all loving me and telling me how brilliant I am, potentially. But
Is
I'll tell
this
you how
because, go on.
well, I was going to tell you why how I definitely don't want to die, which is in reference to these which is to have a fungi infect my brain, making me climb to the tallest tree I can see, biting onto that tree with my teeth, hanging there for 3 or 4 days, and then having fungus sprout out of my head and then spread its spores. That's probably not an ideal topic, and that's what's going to be happening to these ants in today's fossil files.
I mean, I did when I opened this paper and I was like, oh, great, Rob, thanks. This is going to give me nightmares, nightmares for the next week.
So, Susie, this week we're going to be talking about zombie ants in the fossil record. But before that, what have you been up to since we last met?
Oh, I've been on fieldwork in Utah with the University of Birmingham undergraduates.
Oh, lovely. How'd that go?
Yeah, we had a lovely time. We take them to some great places, honestly. Even if I do say so myself, it is a great field trip. They get to go to Dinosaur National Monument. Unfortunately, it was closed. Have you ever been to Dinosaur National Monument, Rob?
I have not, no.
It's an amazing place. So it's all the rocks are kind of tilted upright, and you've got the Morrison Formation, which are the best rocks in the world, as everybody knows. They're where all your favorite dinosaurs are from, all the ones you could name when you were seven, like Stegosaurus and Diplodocus and Brontosaurus and Brachiosaurus and Allosaurus and all those ones. And all those rocks are tilted up, and there's a whole bedding plane which is just covered in dinosaur fossils. It's amazing, and there's sort of a museum built over the top of them. And unfortunately, that was closed, but you can do this incredible walk through like 200 million years of Mesozoic stratigraphy in like a kilometre and a half. It's incredible. It's an incredible place. And then we take them
So,
down, we do some fossil prospecting, we look for some dinosaur fossils we find in Allosaurus ribcage. And then we took them, we looked at some trackways, and then we take them down and dig up ankylosaurs for 3 days. So
nice. So the
it's super
undergraduates
cool.
actually get their hands on some dinosaur bits and pieces.
Yeah, they sit there for 3 days and do some digging. Yeah, yeah, yeah. It's very
Nice.
cool.
How many do you take?
We don't take it. I mean, they're because it's
I mean, how
from
many students do you take? Sorry, I
oh,
mean,
sorry,
not the dinosaurs. Like, how many, how
not the
many,
dinosaurs.
how many vertebrae did you fit in your pocket on your way out there? That's not what I meant.
No, they stay in America.
Good.
No, we took this year we had 14 students,
Nice.
four members of staff. So it's very nice, it's quite civilized. Yeah,
So
it's
you've
very
been
good.
having quite adventures then.
Yeah, and of course it's with some of my favorite people as well. So it's really fun.
Good.
Yeah. How about you? What
Um,
have you been up to, Rob?
I don't know how long I gap till you before you might ask me. I've been on holiday. I went
Have
to
you?
Georgia and Armenia on a little holiday, which is an odd location to go for holidays. This wasn't in any way fossil file related, but I did end up finding fossils. They have some nice street art there. So in the old town of Tbilisi, there was street art everywhere, but there was like this really big Archaeopteryx one, and there was a Gomphothea, and there's all sorts of interesting
Wow.
stuff. So I've put some of that on the Fossil Files Instagram. Go and check that out if you want to. Uh,
Oh, this explains why people kept texting me going, Tbilisi. And I was like, I've
yeah.
got no idea what you're talking about.
No,
Don't know what it's, why are you
I mean,
texting me this?
presumably people understand that we don't go on holiday together as
Maybe they
Fossil
don't,
Files
Rob.
friends. I mean, the Fossil Files hasn't now committed us to taking all our trips together from now onward. But also visited some of the Dmancy, I can't remember how to pronounce it. Dmancy Cave fossils were on display at the Georgia National Museum, which is quite a cool place because those are the first Homo found outside of Africa, if I remember correctly, or some of the first. So that was pretty cool.
Oh,
So they made
oh,
it up
that
to
is
this
cool.
cave very, very early.
So it's an unusual place to choose to go on holiday, Rob. I've not heard of many people going on holiday to Armenia
Yeah.
before. Oh, cool.
But back to fossil files business, I guess. So I at the last one, I asked people to send suggestions, but we haven't actually aired that one yet. So just to give a little, so people haven't been able to make the suggestions. But one of the ones I suggested was fungi, and I just went ahead and found myself a fungi one anyway.
Nice.
Um, So before anyone, so please don't suggest any more fungi ones because we're going to do one. Because this is a weird one about fossil fungi, but really, really weird one. Weird fungi. So before we go into the specific paper, let's talk about fungi in the fossil record because there are hardly any, right? There's lots of fossil plants, loads of fossil animals because they have nice biomineralized things. I mean, presumably you don't think much about fungi in the fossil record at all, Susie.
No, there's not. I'm not aware of there being an extensive fossil record of fungi.
No.
You don't come across it much, do you?
No, it's because they just don't preserve very well at all.
Yeah.
Friend of the fossil files, Russell Garwood. Actually, I'll say he's a friend of the fossil files. He's a friend of. I don't know if actually know if he ever listens. He's worked on some of these things from the Rhynie Chert, where he got some nice ones. But
Oh yeah.
generally speaking, we don't hardly get them at all because they are hard to recognize and also hard to fossilize because they're all soft and squishy. But I mean, that does frustrate me a little bit because we do get soft and squishy things a lot. But also, do we want to go on a problematic side story?
Well, we have talked about Myanmar amber before, haven't we,
Oh,
on this?
I've got a new source of problematic things to go
Oh,
into before that.
oh
Yes.
yes, let's do that. I enjoy
So,
something problematic. Can we see if we can get the suing like done over and done with early?
well, the people involved are probably long dead, so it doesn't really matter so much.
Oh,
I
fine.
know I was looking into fossil fungi and in preparation for this, and one of the names that came up was Mary Stopes because she was the first female academic at the University of Manchester. So, and
Oh,
she was a paleobotanist. So, all
oh,
round, someone that you'd like, oh, maybe that's great. You know, maybe we should have her post on the walls and talk about how brilliant she was. Not so much.
not so
So
much.
she was looking at this coal, Carboniferous coal, and was finding all these little bits of fungus inside. But then she wrote a book called Married Love about birth control. So she was in and which is quite an important issue in the 1920s and 30s.
Mm.
But then she got quite heavily involved in eugenics and sending copies of her book to Hitler and saying, "Please, I love you. Will you share this?" So and also
Wow.
saying and coming out with racial purity and racial and saying that she wanted to forcefully castrate any children born of mixed marriages, so of mixed race marriages. So all in all, not someone we want to put a post. I'm not about to call our new building the Mary Stopes Building for Earth Sciences.
Probably not.
I think she called on Hitler after the war or during the war. I think so. Also, I know people are a product of their time. That's often what's said about these sorts of people, these historic people. But there were people at the time when she was alive saying, "This is you're going too far now." So,
Well,
so
people say that about their grandpas, their slightly racist grandpas,
mm, mm.
not about people who call for children to be castrated, Rob. That's not being a product of your time.
Anyway, that was the sidestep into fossil fungi. I just wanted to give a little University of Manchester flavor with our deeply problematic first female academic. She was generally a kick-ass woman. She went off to do field work in Japan and, you know, largely feminist and was trying to advocate women take control, but then also
Yeah,
went a bit bonkers. Yeah.
yeah.
Anyway, fossil fungi. So
Crashing
we don't
over.
have a lot of them. But this is a weird one with these fossil fungi found in amber. So you did a nice introductory job for amber last episode. So just to give people the reminder, I'll find the name of the paper. This week's paper is Cretaceous entomopathic fungi illuminate the early evolution of insect fungal associations by Yu Hui Zhuang and some other colleagues from, I think they're in Yunnan, are they? Let me have a look which part of China. Yeah, Yunnan Key Laboratory for Paleobiology and colleagues in Europe, Denmark, Czech Republic. Um, so you introduced us to the fossil amber last time. This is another one from Myanmar. Now, do you want to give us a quick recap of the Myanmar amber situation?
Yeah, well, the Myanmar amber situation is complex, as we covered last time, because firstly, it's potentially being mined or quarried by sort of slave labor, at least people who are kind of obliged to do it in very poor conditions by various factions fighting in Myanmar's very, very long ongoing civil war. And those factions are using the proceeds of the sale of the amber for nefarious civil war based means. And
Hmm.
so it's sort of been referred to as blood amber. And the other thing with it is that it is often smuggled out of the country. So it's sold on the black market. And it's actually illegal to export fossils from Myanmar, but fossils get exported as gemstones within amber. So some of the fossils that we see, some of the Myanmar amber fossils have come out of Myanmar, have come out of Myanmar as gemstones. And
Hmm.
that it's a bit of a grey area about whether that's really legal or not. It's sort of
Yeah.
exploiting a legal loophole.
Yeah, absolutely. So there's been a series of, I mean, there's no way you could pretend that you, as a paleontologist, wouldn't be aware of this or as a journal. This has been a series of high-profile papers and discussions about it, one by Emma Dunn and some others, some of her colleagues, where they talk about the legal and ethical issues and how it can be used to fund highly problematic things. So with that in context, this paper came out in June 2025, and I think we should just go straight in with this. This is a quote from their methods. To our knowledge, the fossils reported in the study were not involved in armed conflict and ethnic strife in Myanmar and were acquired prior to 2017. Now, that is the entire ethical statement and discussion about where they came from and how they came from. Thoughts?
Um, well, they've only addressed half of the
Yeah.
uh, ethical issues. I mean, I think generally that 2017 dead cutoff is about when one particular faction took over the amber mines. But
Hmm.
lots of journals have gone further than that and said that they will just outright not publish on Burmese amber at all, no matter when it came out, because the ethical issues are so complex and there's a number of grey areas. They haven't addressed the fact that these fossils are in fact in, I guess, I mean I haven't seen the abbreviations, but YKLP sounds like
Yes.
Yunnan
Yeah.
Key Laboratory of Paleontology. So I
Yes,
guess these fossils are actually reposited in China. So they
they
haven't
are.
addressed how they arrived in China,
No.
put it that
And
way.
also, interesting use of the phrase "to our knowledge." I mean,
To our
that's
knowledge, yeah.
to our knowledge. That's not trying very hard to make the case that this is all above board. But I mean,
I can tell
maybe
you
they're
right
not
now, Rob,
particularly
that would not pass the Natural History Museum due diligence. If
to our knowledge.
if I tried to acquire a fossil and our registrar went, right, I want to see the paperwork on this. Has it been legally acquired? And I went, pretty sure. That would not that wouldn't wash. I have to, yeah, that wouldn't work.
Okay, so I mean, I would invite our listeners, if they want to find out more about this, to go and read that paper from Emma that I talked about last week and think about what the implications are for this one. We're starting with this enormous blaring caveat at the beginning of this, is that these fossils have come from the middle of a very dangerous area, and we haven't got a proper paper trail of how and where they were purchased or by whom, and they now ended up in China, not in Myanmar. So let's talk about what they've actually found. So these guys have got some fossil ants. Now, fossil ants and insects in amber is not unusual, not just from Myanmar, but from Dominica and Baltic amber and other places. Some really lovely preservation of insects is possible in amber. You get nice, crisp, beautiful anatomical details. Sometimes you can just see them without having to use any fancy technology. Sometimes you want to take them to the synchrotron and have a nice X-ray of inside of what's going on. But before we get to that point, why am I talking about these ants? It's because I started talking about fungi and ways to die, is because they have found evidence for what they suggest are these, if I can say the word again, entomopathogenic fungi. Now, this is fungi that eat insects and can change their behavior in weird ways. Have you come across these fungi before?
Um, have you seen The Last of Us?
I haven't
Oh
seen
my
it, but I know
God.
it's, have you seen it and played the game? There's a
Yes.
game, right? So tell me about the program.
Okay, I don't. I'm not a gamer. I can't comment on
Okay.
the computer game, but yeah, I think it is based on that, isn't it? Well, it's basically, a sort of post-apocalyptic world where these fungi eating zombie ant things, where the fungi is basically, it's jumped to humans and you grow a fungus and it sort of explodes out your head.
Yeah.
Broadly. Yeah, that's pretty
So
much the
yeah, the way these
storyline.
fungi work is that they will infect an ant. They'll, well, it's not just an ants. They can do it to spiders, as famously, and all sorts of insects. But spiders and ants are the ones that are perhaps the most famous. This fungus will, burrow into the body, get into the hemocoel. Is that the right word? I can't remember the cavity inside with the fluids, and then they can do weird stuff by making you change the behaviors. Now, I'm quite interested in what the mechanism is. How do they change the behavior of the organism once they're inside it? But that's where they ask these ant ask. They don't ask. It's not like a conversation going on. The ant or the spider will then go up to a space, climb quite high, find itself exposed, or in the case of these ants, bite onto a leaf and they just hold on in a death grip. And then the spores come out of their head and explode. So
Ah!
Yes, yes, it's horrifying. And this paper has some nice pictures of that. So it's called Cordyceps is the sort of loose term for this. It's quite now the thing that I'm gonna have to ask everyone to forgive me in advance because fungi are not my specialism. But and also there are lots of different species that have done this, right? They have evolved to invade, there's a really interesting evolutionary dynamics going in here. This happens quite a lot with parasites going into different hosts and the dynamics of that. They can evolve with the host, they can evolve, they don't want to necessarily kill the host completely, but they also can jump from different species to species. That's the premise of Last of Us, I guess, where this insect species jumps into a human and can change our brain and make us zombies.
Yes. Do you know, I'm actually not that much of a fan of insects. I don't really like things with more than four legs. So, um, spiders, right out. Had to get my husband to remove quite a small spider from the shower this morning before I was willing to go in. Um, so fungus bursting out of already creepy crawlies. This is I'm fine. I don't even want to look at it. I'm looking at figure one and it's actually quite gross.
Well, before I get onto figure one,
Gross.
I'm quite surprised about your squeamishness because you go on you're a hardy fieldwork ready kind of person. You've go to
No,
all
I
sorts
like
of
the
places in
rocks.
Central
I like the
Asia and
rocks.
yeah, but who lives in the rocks? The creepy
Well,
crawlies live in the little. I mean, every time I'm doing fieldwork, I'm putting my hand inside thinking, what's in there? Right? You're not
yeah,
worried about that?
yeah, yeah,
Yeah.
yeah.
Okay. Okay. For the
I just
for the
make a
sake of
lot of
the listeners,
noise.
Susie's not looking impressed at this. She's sort of nodding slowly with a dead-eyed glaze on her. She's not impressed about the
I
creepy crawlies living in the crevices.
No, I don't like the creepy crawlies. But I mean, the thing on fieldwork is that most things want to kill you, right? I mean, where we do fieldwork in the States, there's like mountain lions and bears. They definitely want to
Yeah.
kill you. And so, there's scorpions and snakes and things like that. I don't mind snakes. Not that keen on bears, to be honest.
Mm.
But yeah, I'm spiders, no, no, right out.
I think if I take my students to Mallorca, I think the only risk they're going to be facing is drunk British tourists. So I think they'll probably, or Germans. Let's be fair, the Germans love to go to Mallorca and get drunk too. That's yeah. Anyway, so let's get back to these this fossil and this fungus. So these guys have described they've got about three or four fossils in amber of these ants. They describe what they see as fossil structures that are related to fungus. Now, one thing that frustrates me slightly about this paper is that they just dive straight into describing this as, the using the very technical language of the fungi and the stoma and the paratheca and all that sort of business. I would have liked to have started with a bit of, you know, why do we think they're fungi? Because what we've got is some ants with some bits sticking out of them. I think we need a bit more walking into this rather than just immediately assuming they are fungi. I think that seems like quite a missing part of the story.
I agree, but actually, I found the figures quite compelling because they've
Yeah.
presented a number of panels in the figure which shows the sort of the fossil CT scan, and then they've
Yeah.
also shown the same in a
Yes.
living fungus and a living ant, and I thought that was quite compelling. Actually, they look very
Yeah.
similar, although you have to draw that conclusion yourself. That is true.
Well, let's start with figure one. I won't describe it all.
I'm just going to do this all the way through. It's gross.
We've got an ant pupa, and they've got a picture of it, and then they've scanned it. We used synchrotron technology. We've mentioned this before, high-powered X-rays to create a 3D model of the internal anatomy. And then they've got this sort of, so it's not quite fully formed, this pupa, because it's quite young, but it's also got this sort of structure coming off the side of it that's, I don't really know how to describe it.
It's like a fan. It's like a fan-shaped thing spurging
Yeah,
out of the side.
looks a bit like, what do you call those little isopods that live on land? Pill bugs.
Wood lice?
Woodlice, yeah. It looks a little bit like a woodlouse, that sort of
Yeah.
shape with little grooves on it. And that's characteristic of a stoma of one of these fungi. They've got some pictures of what they look like, as they burst out of an ant body and sort of start these fruiting bodies full of spores. And they're covered in what they think are these little peritheca, which are the tiny tufty bits on the top. But I wasn't massively convinced by that because these are just little tiny tufty bits or balls that. But anyway, the shape and morphology of this thing is quite consistent, and it's not just a blob, right? It does seem to have some chambers and a shape that are
Yeah, the
distinctive of these
internal the
things.
internal structure looks
Yeah,
quite
yeah,
similar to the internal structure of the living one which they show.
yeah. So they relate this to a clade of paleo off. Oh god, this is going to be hard to say. Paleo Cordyceps, and then they give it a new species. And then in the second picture, they've got some more. These are adults this time, and they've got the more classic sort of like club coming out of its head. Now again, I find this a bit frustrating because it's just a club, right? How can you tell me that is a fungus? I mean, the first one has that probably a bit more morphology. This one's just like a something sticking out of its head. But again, they show this alongside some pictures of what the insects alive today look like, and it is just basically a sort of fruiting body sticking out of a head.
It's
Now,
gross.
it's
Gross.
gross,
It's
gross.
gross. It's an
One of the
insect
questions
with a fungus sticking out of its head. It's really upsetting.
I didn't realize this was going to be what you seemed more chilled out when I talked to you about how you want to die than you are
Yes.
making you look at pictures of insects with bodies coming out of them.
Much, much less distressing question.
I don't understand that at all. So I wanted to ask you a question about this because they've got some lovely photos here, but I wanted to ask about drawing. Now, paleontologists often have to use drawing to sort of, and there's a reason for doing that. Although I am kind of frustrated that a lot of geologists I talk to think that, a lot of geologists, when they have training, they think that they don't like paleontology because they think paleontology in their first year, they're all made to draw a trilobite. And that's what they think paleontology is. They're like, no, 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 no. Biologists, we approach it from a different direction, right? We look at the history of life on Earth and evolution, and then we look at big picture stuff. And then slowly we come to the sort of drilling down into it. You were a geologist. Were you made to draw a trilobite in your first year?
Yeah. And an
Yeah.
ammonite. Yeah, 100%. I mean, I got to say, right, that anatomy. So you do, as a paleontologist, you do need to learn some basic aspects of
Yeah.
anatomy, right? You need to, but just so we have a common language, and things,
Yes.
particularly things like trilobites, are, there's a whole language associated with their body parts that
Yeah.
isn't the same as, you can't just say legs
Hmm.
or body segments. There's bits
Hmm.
that you need to be able to talk about, and it's really hard to teach anatomy in an engaging way, isn't it? And I
Yes.
think, medical students, when they're learning anatomy of humans as well, it's you really just have to learn it. There's really no shortcut. And
Hmm.
I think that's part of the problem with sort of undergraduate paleo is that if you have to learn anatomy, it's really, really boring.
So
Um,
I guess that's one part of it, but I wasn't even thinking of that. Like learning that the trilobite has three parts and one of them's the pygidium and the other one's the cephalon or whatever, then that really puts up a lot of people for what they think that's what paleontology is, learning
mm,
all these technical terms, but
learning
it's not that.
anatomy. No, it's not that at
Whereas
all. But we do need a common language.
yes. However, I was going to pose that drawing, the reason I'm in defense of drawing isn't because of learning anatomy, but because it forces you to interpret anatomy, think about how bits are connected, which bits are discrete structures. And that's true of vertebrates, invertebrates, plants, whatever. I think I think
But
I would strongly recommend it.
it's also something that we make students do as geologists as well, because
Yes. Indeed, yeah.
it forces you to observe much more closely, right?
Yes.
So if you're drawing something, you observe it much more closely. So we were making students do field sketches. We always have field sketches last week in the field.
Yeah.
When we were learning mineralogy, we would sketch what was down the microscope. It's
Hmm.
not just paleontology where you're doing lots of sketching. It is, I think it's about observation and observing things closely.
Yeah.
And also taking a photo is never as good, is it? Because you can
No.
take a photo, but you can't label it, you can't see those all the
Yeah.
details. You
Yeah.
can,
Yeah.
in a drawing, you can bring out the details that you're interested in. And I don't think that's a skill that's unique to paleo, or something that's useful just to paleo. I think
Hmm.
actually across certainly all of the things that I've done in my
Yeah,
training, it's
absolutely.
been
And
useful
I
too.
don't, I don't want to put people off who are thinking about paleontology is that, you have to be, I'm not artistic. It's not about it's not artistic at all. This isn't about you like drawing, how does this trilobite make me feel? Here's my impression and interpretation of it. No, it's very much like a technical, more like an architect, right? You're
Yeah.
drawing the lines, you're making the connection. And obviously there's a lot of technology to help with that now, but even, I mean, just thinking about that, you could use AI to get a drawing, but it would be completely pointless because the whole point of doing the drawing is that it's your interpretation. It isn't the end result. It's the process of doing it that can identify what you think the morphology is. Anyway, this paper reminded me of that because I was thinking I could really do with some drawings here and some proper labels that you could know what we're looking at. But maybe that's
A
just
bit
because
of
I like drawings.
interpretation. I agree with you that some interpretive drawings would not be amiss here. It would be very helpful if they had some.
Yeah, yeah. Okay, so let's move on then. Also, a side note, I guess I always make my PhD students for drawings, and they often get a bit upset with that. Um, Jane in particular wasn't a fan, although Jane doesn't like it when I talk about her on the podcast, so I probably should.
Hi Jane.
Hi, Jane. Everyone's so Jane Reeves. Her name is Jane Reeves.
Hi
Okay, so
Jane. She does our
hi,
social
Jane.
media. Hi Jane.
Hi, Jane. Okay, so the next thing they did in this paper was they did a nice phylogeny based on the molecular sequences of the fungi, and then they did some nice divergence time estimates. So that's kind of nice because with these. fossils with fungi and with parasites generally, it's always very hard to get any calibration points. If you're doing a nice phylogeny and you want to know about the evolutionary tree and you want to know about what the evolutionary rates are related to major events, that's actually quite difficult because you don't often have fossils. Whereas they've now got two fossils that they can use to calibrate this tree to sort of reconstruct rates of evolution through time. So that's nice. One of them
And
is
what it
their own
told us,
data. Sorry?
and what it told us was that this fungi had been doing horrific things for much longer than they thought.
Yes. So there's two calibration points in this phylogeny. One is their own data. The other one was one from the Messel pit in Germany. This is after the extinction of dinosaurs. This is about 41, 51 million years. I can't remember the numbers. And this is a leaf with holes in it where the insects have been, they interpreted the traces on this leaf as the death grip of all these insects, which I thought was quite a cool use of a fossil
Mm.
record to get that. And we've got plants in now. Right, that's it. Plants are done.
Tick.
Thick. And they also provided a sort of rundown of the history of different proposed interactions with between fungi and animals, because a lot of them are insects, right? So they talk about the association and the host. So that's fun. I quite like that approach to evolution. If you can look at how things have jumped from one host to another, and you can look at the time frame of when that was happening and how frequently that was happening with ancestral state reconstruction. So that's fun. But I also came across something a bit surprising in their supplementary information when they had this big long list of potential examples of where fossils have indicated interactions between fungi and animals. Most of them were insects. A lot of them were described as dubious, but one of them was dinosaurs.
Ah, no, not vertebrates. Ah.
Don't worry, they're not eating dinosaur brains as far as they're aware.
Is it
I was
athlete's
just,
foot? If we recorded a first
no,
case of athlete's foot.
I don't know how if athlete's foot would be recorded in a fossil or in a dinosaur. I presume if you're scaly, you don't get athlete's foot, but maybe you get
Oh,
something
I
else.
don't know.
You're often quite dry if you're a lizard, aren't you? Anyway, I'm now thinking about the moist environments that athlete's foot thrives in, and it's making me creepy. Let's have a look at the this dinosaur example. So this was one that I hadn't come across. This is okay. So the other example was from China from 2008. Endolithic fungi, a possible killer for the mass extinction of Cretaceous dinosaurs. So this is a Chinese fossil dinosaur egg, and they zoomed into the shell and found tiny little mycelium, which are these sort of branching structures, potentially for fungi. And they have interpreted it as potentially these eggs were getting infected by fungi and being part of cause of mass extinction. Now, that's an interesting idea. Presumably you haven't come across this idea before.
I've got
Let
all
me,
sorts of questions. First, my first question is where on earth
yeah.
was that published?
This was published in the Science in China Series D Earth Sciences,
Uh-huh. Okay.
and it's been
Um,
cited a handful of times. I'm not sure this is a theory that's going to take over and become the new dominant one. Also, the idea that this is the extinction course for dinosaurs is perhaps a bit out there because
it
I
might
think
have gone, they might have gone a
we
bit further than actually the evidence allowed.
we have quite a lot of information about what the dinosaur extinction was about. I think we're well beyond the case. We are looking for mysterious diseases and other things now.
How did they distinguish between the fungus occurring prior to the dinosaurs hatching out of the eggs and afterwards?
Oh, that's a really good question. I think this paper is not, I haven't read it properly, so I don't know, but I'm not sure it's that detailed. But yes,
Mm,
that's a good point. What happens to, I guess this is the really interesting question is that if you want to get into this, you'll need to look at what happens to eggs nowadays. Do eggs get infected? And what happens once you cracked out of the egg, there'll be loads of different bits of that need to go back into the environment. And that's what fungi do, right? That's
absolutely.
their whole raison d'etre is that okay, there's something for me to eat. It's dead. Sometimes it's alive, but mostly it's dead. And
Yeah.
I will just
So,
return this to the biosphere.
well, and I mean, I guess one way you could test that is are the eggs whole or had they hatched? Are there embryos inside or are they not? But even then, you still couldn't rule out the possibility that the embryos had died and the eggs were
Yeah.
rotting. And actually, the process of rotting is through fungal invasion and breakdown. That's, I mean, as you say, that's what it does. That's what fungus does. So
Well, that's where I can bring
that
in
sounds
my
like,
other PhD student, Felicity. She's been looking at the microbes that are on decaying organisms, and we've been looking at the fungi. Most people look at bacteria, but fungi haven't really been looked at a lot. So there's a, oh no, I
lucky
should be quiet
her.
now. She loves it. She's been going on these deep dives, telling me all about these horrible fungi. She even found in some of our samples, she found some of these Cordyceps ones, which is a bit alarming because Susie's face is now we are right. Okay, if I start talking funny and like climbing onto the top of buildings, then maybe if Felicity and I start biting things with a rampant, carefree aggression, then you might know that we've gone wrong. Okay, so I guess that was the end of the paper. They found these things in amber. They haven't really explained how or why that's all okay. Uh, they have these fungal things on them. I'd like to see some drawings, but that's okay. And that allows you to look at some interesting evolutionary history of these things. I mean, it doesn't actually rewrite the history of them or not. I mean, we knew they were leaping around between species, but it's an extra data point on that.
It's more detail, isn't it? I mean, they've got what they've got is they've pushed the origin of these bacteria, these fungi back. You know, when they
Yeah,
first invaded ants and stuff, um, by 30 million years or so. Which
yeah,
that's most of the papers that we talk about are people discovering that things are older than they thought they were before.
yeah.
But so they've pushed that back into the early Cretaceous, um, and they have then put some sort of, I guess, quantification on when when fungus moved
Mm,
into
mm.
various different clades. So
Yeah.
it's more quantitative than it has been previously, I guess.
Well, I guess also you've got just such a paucity of data with these things, right? If
Yeah.
you want to reconstruct the evolutionary history of parasites, it's really, really hard because you know, if I want to look at the evolution history of, I don't know, lizards, I have fossil lizards and I can use that. And I can even think about paleobiogeographic events to constrain things. When was the breakup of Pangaea?
Mhm.
I can think about that. If I'm trying to think about the evolution of, I don't know, syphilis, and I use that example pointedly, not because well,
Not because
going
it's on
back
your
to
mind.
no, because Mary Stopes was also there
Ah.
was a suggestion that oh, wait a minute, let's not go into the Mary Stopes. I don't want to slander. She sued someone for being slanderous about her when she was alive, and I think syphilis was part of it. Anyway, the point syphilis is also interesting because there was a theory that it came from the New World, like when I shouldn't say New World from the Americas, but when there was the big interchange, Columbian interchange of people from Europe going to North America and North Americans coming from Europe, the Europeans brought loads of horrible diseases with them, which had an awful effect upon the indigenous peoples of North America. But there was a suggestion that syphilis was one of the diseases that came the other way. So you can look at when you think about the evolutionary history of diseases moving about, you can do those sorts of things. I'm not sure that theory holds any weight anymore, but because there was plenty of other. My goodness, this has taken a weird turn. I shouldn't have just randomly started talking about sexually transmitted diseases. Right, forget all of that. Delete. The
I
the
thought that
point
was quite
was
interesting, actually, Rob. I didn't know that.
okay. Well, I mean, I should fact check these things before I start talking about them. But in terms of diseases, it's really, really hard. So you could look at the diversity of diseases alive today and not have any idea about when or how any of that happened. So in this case, we've got like two data points now, which is, is going to take a lot of work to get any more than that. But for most diseases, especially these sorts of parasites, we'll have nothing.
Yeah. I mean, I guess it's also worth saying that, the reason probably that people keep on working on this very controversial amber is because it preserves things like this, right? That
Hmm,
other
hmm.
fossils just don't preserve, because amber effectively is able to preserve tissues that aren't normally preserved in the fossil
Yes,
record.
yes.
Um, it means that you get these incredibly spectacular and detailed fossils with incredible sort of very fine resolution. So in these pictures of these fungi, you can see the spores and
Hmm,
everything. At least they
hmm.
claim you can. I'm quite taken with them. I think
Yeah.
they're quite it's quite they're quite convincing. Um, but we just don't get that level of detail in normal fossils, in
No,
fossils
no.
preserved in rocks and sedimentary sequences. So I think the amber thing, I think part of the reason why people persist on publishing on this stuff is because of these incredible fossils that you get.
Yes, I guess this raises an interesting question though about like,
Science at all
well,
costs,
science at
or
all costs.
science
Yeah,
at
like,
what
does it
cost?
matter? Like, I mean, as you talked about when we talked about last time, really on the scale of things, no matter how lovely the fungus is, if it's, coming from ethnic strife and funding civil wars and
Absolutely.
genocide, then really, I mean, are we saying that at what point does that graph cross over of scientific value against ethical problem? I don't think there is really a crossover, is there?
I think I could have lived without knowing about these ants. I mean, I like happily, you know,
Well,
they
I
could
think
have
you
just
would have
kept it to
preferred not to know
themselves.
anyway, irrespective of the science. You just didn't want to look at the pictures of these
No.
things. Well, irrespective of whether this paper came out or not, these fungi are out there doing this thing. Side note, these fungi are actually really interesting because they have parasites of them. So the
Do
fungi
they?
that yeah, so they have interesting properties that biomedical people are looking into because they whether they could be used for sources for cancer, antimicrobials, things like that, because they have quite an interesting physiology. So there's the parasites on top of the parasites, which is something to bear in mind.
Well, that's good. I mean, at least something's getting the fungus back. The death-eating, zombie-forming fungus. At least something else is.
Okay. What's your take-home message here?
Don't
None.
read papers about fungi without, if you don't want nightmares.
Okay.
My take-home
Right.
message.
Thank you
Let's
very much,
never ever look
Susie.
at one of these again.
Right, fungi is done. At least not we've done fungi, that's now done. Um, next time, I was hoping you might talk to us about pachycephalosaurs. I haven't actually
Oh,
asked you about this before. And
can I do the cool pachycephalosaur paper? Okay, yeah,
yeah,
let's
how
do
did the
that. That's fun.
pachycephalosaur get its dome? I think that would be an interesting paper for us to cover next time.
Okay, yeah, let's do that.
Cool.
Fun.
And
I
I
haven't
thought I
read it
might
yet, so it'll give me an excuse to as well.
lovely. All right. Thanks, Susie. See you then.
See you then.
The Fossil Files was presented by Robert Sansom and Susanna Maidment. You can find more information, including links to the original papers that were discussed, at fossils.libsyn.com, and you can contact us at fossilfiles.pod@gmail.com.